blindness with their own cells.
This is my advisor, Dr. Dennis Clegg, and recently we've had an opportunity to work with this young woman, Lily. Sadly, Lily is going blind. She has a typo in her DNA that's causing the cells in her eyes to degenerate. And as a cell biology lab that studies blinding diseases, we're interested in trying to help Lily. We want to know if we can find exactly where that typo is, and if we can fix it, could we possibly treat her disease? Could we maybe take her disease cells, edit her genetic mutation, and then use those healthy cells as a therapy? In other words, can we personalize medicine to the level of using someone's own cells as a cure to their blindness? Before I can answer that, we have to talk about stem cells. About 10 years ago, scientists discovered that you could take a skin sample from a person and turn those skin cells back into fully functioning stem cells that can become any cell type in your body. And more recently, scientists have figured out how to get into those cells and edit a typo. The image on the right are cells that I made in lab that were originally a skin sample from a patient like Lily, for which we made stem cells, corrected the mutation, and are now studying the eye cells in lab. Not only can we make one cell type at a time, we can actually make entire small tissues. The image here is the cross-section of what is essentially a miniature eye that was grown in lab from healthy stem cells. And what I'm showing in red is where your light-sensing cells are, whereas in green is the protein directly involved in Lily's disease. We were successful in finding where her typo is, and we now know how to grow those healthy cells in lab. So the answer to my original question is yes, we do have the potential to take a patient's disease cells, edit their typo, and use their healthy cells as a therapy. But before we can do this, we need to make sure that we're making the correct cell type, that we can edit the typo efficiently, and that we can safely transplant these cells back into a patient. If we can figure this out for Lily's disease, it will give hope to so many people who suffer from genetic diseases. Thank you.